The topic today that we'll be doing is group 17 or group 7. The first thing that we will study about group 17 is the physical properties. Now we know it starts with fluorine and ends on astatine. So first is fluorine, bromine, iodine, and astatine. But the basic properties that we will be focusing on are for these three elements, which are fluorine, bromine, and iodine. And obviously, the trend will continue for fluorine and astatine. Let's understand the color and volatility. What is volatility? Volatility is the property that relates to boiling point. The liquids that evaporate quickly are called volatile liquid, like perfumes are called volatile liquid. That means इनका boiling point कम होता है. Volatility is technically relating anything to the boiling point. So chlorine is a greenish yellow gas. Bromine is a red-brown liquid, and iodine is a dark gray solid. The exact color that is mentioned in the file, that is the color that it looks like. And what do you see about the volatility? That chlorine is a gas, fluorine is also a gas, chlorine is a gas, bromine is a liquid, iodine is a dark gray solid. Can you predict astatine? What will astatine be? Solid. Obviously, the boiling point is increasing down the group, right? And we can see that with the graph as well, that the boiling and the melting point increases down the group. Why does that happen? Why does the boiling or the melting point both increase down the group? Specifically, we'll talk about. Very good. We discussed that in the intermolecular forces, that boiling point is a measure of the strength of intermolecular forces, right? When we talk about molecules. So the higher the boiling point, the stronger the intermolecular force. All of these exist as non-polar molecules. Chlorine के अंदर Cl2 का molecule होता है, bromine के अंदर Br2 का molecule होता है, and iodine has an I2 molecule. It's non-polar, so we cannot talk about polarity. And if it's non-polar, what kind of van der Waals forces is there? Van der Waals, कौन सी van der Waals is the general name for all intermolecular forces. Temporary dipole or induced dipole, or we also call them London forces or dispersion forces. So yes, there are just dispersion forces, and dispersion forces increase with the size of the molecule. So as we go down the group, the size of the molecule increases, and so does the strength of the dispersion forces, and hence the boiling point increases. Is this clear? Okay. Now let's go to the chemical properties of their hydride. Now, what is a hydride? Let's try to understand their reactivity as oxidizing agents. What do these elements do? For example, if I take any element, if I take the element chlorine, it's a chlorine gas. It has a tendency to gain electrons and form a chloride ion. Similarly, if I take bromine liquid, it will gain electrons and try to become a bromide ion. If I take iodine solid, the iodine will try to gain electron and become iodide. So that is their general tendency. All of these tend to gain electrons and form halides. Is this clear or not? तो अब हम चेक करेंगे कि भाई जब सब everyone wants to gain an electron, तो किसकी ज्यादा strong strength है to gain an electron? बात समझ आ रही है? How do we do this? It's a very easy experiment. हम fluoride को इसमें से निकाल के let's try to understand. Now what do we do? So what? क्लोरीन और ब्रोमीन को नहीं कराते आपस में, बिकॉज फिर तो इलेक्ट्रॉन दोनों के पास ही नहीं है. What do we do? हम ब्रोमीन को इलेक्ट्रॉन देते हैं. We have a bromide ion, and then we put a chlorine gas in it. इसका काम किस तरीके से करते हैं? For example, we take a solution that has a bromide ion. Hydrogen bromide solution हो गई, sodium bromide solution हो गई, and then you pass chlorine gas through it. So what does chlorine do? Chlorine is a stronger oxidizing agent. Chlorine क्या करता है? उस bromide से इलेक्ट्रॉन छीन लेता है खुद वो क्लोराइड बन जाता है एंड इट फॉर्म्स अ ब्रोमीन। तो अभी बॉन्डिंग तो नहीं, अभी हम वी आर टॉकिंग अबाउट ऑक्सीडाइजिंग और रिड्यूसिंग पावर। फॉर एग्जांपल यू टेक सोडियम ब्रोमाइड सॉल्यूशन, यू हैव द salt of sodium bromide, आपने उसको पानी में डिसॉल्व किया, it has a sodium bromide solution. Now you pass chlorine gas through it. Chlorine से इलेक्ट्रॉन ले लेता है, फॉर्म्स क्लोराइड आयंस और वो ब्रोमीन लिक्विड या ब्रोमीन वेपर्स बना देता है। Similarly, chlorine has stronger strength, enough strength to take electrons from iodide too. So it can take electrons from iodine and bromide. So this shows कि क्लोरीन जो है वो इन दोनों से ज्यादा स्ट्रॉन्गर ऑक्सीडाइजिंग एजेंट है। अगर हम वो इलेक्ट्रॉन ले, रिमेंबर इलेक्ट्रॉन, अगर मैं एक्स्ट्रा इलेक्ट्रॉन दूंगा तो दैट विल हैव टू गो थ्रू अ टग ऑफ वॉर, इमेजिन इट एज अ टग ऑफ वॉर, कि जो वो इलेक्ट्रॉन ले लेगा वो ज्यादा स्ट्रॉन्ग अच्छे से रिड्यूस हो जाएगा, तो खुद रिड्यूस हो रहा है, तो दैट इज कॉल्ड एन ऑक्सीडाइजिंग एजेंट, राइट। तो हम वो इलेक्ट्रॉन बीच में नहीं रखते, इलेक्ट्रॉन एक को दे देते हैं। हम कहता हूँ कि ब्रोमाइड को दिया, वी टेल क्लोरीन ओके से लेकर दिखाओ, क्लोरीन ले लेता है। आयोडाइड को दिया, क्लोरीन आल्सो टेक दैट अवे फ्रॉम आयोडाइड। दैट मींस क्लोरीन इज अ स्ट्रॉन्गर ऑक्सीडाइजिंग एजेंट देन ब्रोमीन एंड आयोडीन। इज क्लियर? सिमिलरली वी डू द सेम विद ब्रोमीन। हम ब्रोमीन लाते हैं और क्लोराइड को अगर दे देते हैं, so bromine cannot take the electron from chloride. But if I react bromine with iodide, तो iodide से इलेक्ट्रॉन ले लेता है। इससे हमें स्ट्रेंथ का पता चलता है, देयर ऑक्सीडाइजिंग स्ट्रेंथ। क्लोरीन आउट ऑफ द थ्री इज द स्ट्रॉन्गेस्ट वन। ऐसे देखा जाए तो फ्लोरीन इज द स्ट्रॉन्गेस्ट ऑक्सीडाइजिंग एजेंट, देन क्लोरीन, देन ब्रोमीन, देन आयोडीन एंड देन एस्टेटीन। और आपस में हम इनके ऑक्सीडाइज किस चीज की स्ट्रेंथ, बी वेरी क्लियर अबाउट इट, ऑक्सीडाइजिंग स्ट्रेंथ, सही है ना। कहते हैं कि या हम कहें इलेक्ट्रॉन गेनिंग स्ट्रेंथ, सही है ना, कि हाउ इजीली दे आर रिड्यूस्ड और हाउ गुड दे आर एज ऑक्सीडाइजिंग एजेंट्स। इट इज क्लियर? सो फ्रॉम क्लोरीन to iodine, the oxidizing strength decreases. Chlorine is the strongest oxidizing agent out of all. पहले हमने टेस्ट कैसे किया? The first reaction that we did was कि दोनों में से एक को इलेक्ट्रॉन दिया, we gave the electron to one of them and we asked, we replaced or we added the other one as an element, and we saw whether the element takes that electron back or not, it takes away that electron or not. So chlorine did that with both bromide and iodide. Chlorine तो दोनों से strong है. And then we did that with iodide, so bromine took that electron from iodide as well. So we said अच्छा भाई तीनों में से कौन है जो सबसे खींच रहा है? Chlorine. उसके बाद bromine did not take that away from chloride. Bromine chloride से electron नहीं ले पाता, but it does take that electron away from iodide. So we say okay fine, strongest chlorine, दोनों से छीन लिया electron, then bromine and then iodine. Is this clear or not? So this is the first reaction which we use to compare their oxidizing, their ability as oxidizing agents. Is this clear? इसी का एक और reaction है, we can react them with iron as well. And what is that reaction? It's a very good reaction. Try to understand. When we react chlorine with iron, chlorine gas को iron के साथ react करते हैं, so it forms iron 3 chloride. Initially iron, what is the oxidizing state of iron? खाली आयरन अगर है तो व्हाट इज इट्स ऑक्सीडाइजिंग स्टेट, ऑक्सीडेशन नंबर क्या है इसका? खाली आयरन है, जस्ट आयरन मेटल। वेरी गुड। तो नहीं होगा तो व्हाट डू वी से? जीरो। ऑक्सीडेशन स्टेट इज जीरो से इसने आयरन को +3 का आयन बना दिया। इससे वी कैन अंडरस्टैंड द ऑक्सीडाइजिंग एबिलिटी ऑफ क्लोरीन। इसने आयरन को जीरो से कितना ऑक्सीडाइज कर दिया? +3। इज दिस क्लियर? नेक्स्ट इन लाइन हम कहते हैं अच्छा ब्रोमीन, सब तुम करके दिखाओ कितना करोगे। तो वी रिएक्ट आयरन विद ब्रोमीन, ब्रोमीन भी +3 कर देता है, बट द डिफरेंस इज कि आयरन हमारे पास क्लोरीन के साथ कम टेम्परेचर पे कर जाता है और ब्रोमीन के साथ उसको टेम्परेचर थोड़ा सा ज्यादा चाहिए था, और वी कैन से दैट इट रिएक्ट्स लेस विगरसली विद ब्रोमीन। दोनों ऑक्सीडाइज बराबर कर रहे हैं, वो भी +0 से +3, ब्रोमीन ऑल्सो डज दैट 0 to +3। तो इससे क्लोरीन और ब्रोमीन के आपस का नहीं हो। वैसे हम डिसाइड, वी हैव ऑलरेडी डिसाइडेड आपस में जब सबको लड़ाया था तो वी फिगर्ड आउट ओके क्लोरीन इज द स्ट्रॉन्गेस्ट ऑक्सीडाइजिंग एजेंट out of the three. You've already figured that out. But in this reaction, we cannot differentiate between chlorine and bromine. The only way we can differentiate is by figuring out how vigorous the reaction is. The reaction with bromine is less vigorous than it is with chlorine. Is this clear? तो इससे पता चल रहा है हाँ दोनों 0 से +3 तो ऑक्सीडाइज कर रहे हैं बट क्लोरीन ज्यादा एनर्जी के साथ कर रहा है. So chlorine is a stronger oxidizing agent. But we cannot, मतलब इसको clearly we cannot use it as an indicator to explain the strength between oxidizing power of chlorine and bromine. What happens once we do that with iodine? नहीं, iodine शुरू में again iron was 0. इसमें iron का oxidation number क्या है? Fe2 में iron का oxidation number is +2. तो उसने iron को 0 से +2 ion बना दिया. So that explains how good iodine is as an oxidizing agent. तो उसने iron को 0 से +2 कर दिया. What about bromine and chlorine? दोनों ने 0 से क्या कर दिया था? कौन ज्यादा stronger oxidizing agent है? Bromine and chlorine. उनको भी कैसे कंपेयर करेंगे? Iron का रिएक्शन क्लोरीन से ज्यादा विगरस है. So with iron, chlorine is a stronger oxidizing agent. So this is the second reaction to compare their oxidizing power. First was when we used the element of one and the ion of the other to compare their oxidizing power. Is this clear? समझ आ गई बात? Another reaction to compare their oxidizing ability is reacting them with sodium thiosulfate solution. Now this is something that you need to see and understand. Okay, when it reacts with chlorine or bromine, the sulfur containing products, उसकी detail में हम नहीं जा रहे. Basically, sodium thiosulfate is Na2S2O3. Can you figure out the oxidation number of sulfur in this? When we react sodium thiosulfate with bromine or chlorine, this is sodium thiosulfate Na2S2O3. The oxidation number of sulfur is 2 in this. So the final product that it forms with bromine and chlorine is Na2SO4, in which the oxidation number of sulfur is 6. So that means it oxidizes sulfur from +2 to +6. It shows the strength of chlorine and bromine as oxidizing agent. But when it reacts with iodine, it forms this. So what is the oxidation number? But what is the oxidation state of sulfur? It goes from +2 to +2.5. You can figure out the oxidation number of sulfur in this. That is 2.5. So इतना इसकी oxidizing power है कि इसने +2 से sulfur को 2.5 कर दिया. This shows that iodine is a weak oxidizing agent as compared to chlorine and bromine. Is clear or not? So these were different reactions that we did to compare the strength of oxidizing or the oxidizing ability of chlorine, bromine, and iodine. Is this clear? Okay, now when we react them with hydrogen, what basically happens? Fluorine, when we react with hydrogen, it combines explosively because fluorine is highly reactive and it forms HF, which is hydrogen fluoride gas. Is this clear? And this reaction can happen in the cold and dark. When we say cold and dark, what does that mean? We are not providing any other external assisting or initiating factors. ना हम उसको अलग से energy दे रहे हैं, क्योंकि sometimes जब हम dark का मतलब ये हम ultraviolet light भी provide नहीं करें, because UV light से it tends to initiate reactions in halogens. UV light tends to initiate reactions in halogens. We are doing it in dark. That means we are not providing any initiating factors, neither in the energy and in the case of thermal state, nor in the light state. Is this clear? So chlorine and hydrogen explode exposed to sunlight or a flame. Obviously, अगर हम energy दे रहे हैं तो chlorine और hydrogen फिर वो explosively react करते हैं, but fluorine को तो कोई energy ना भी दें तब भी it reacts explosively. Just go through these observations. Similarly, bromine के साथ जाते हैं तो और mild reaction होता है, and iodine के साथ it is a much more mild reaction. So that shows that the reactivity of halogens decreases down the group. This is a reaction which proves that the reactivity of halogen decreases down the group. Is this clear? And with iodine, the reaction is also reversible. Equilibrium established between hydrogen iodide and iodine and hydrogen. Is this clear or not? Anything that is bothering till this point? Now let's talk about thermal stability of the hydrogen halides. Once these products are formed, how easily do they break on heat? So HF, HCl, when we try to heat them, जब ये product बन गई हैं HF, HCl, HBr, we try to heat and try to see कि heat पे फिर ये break कितनी आसानी से हो रही है. Because HF was so eager to form, should it break easily? No, so it does not break easily. It's a stable product. It stays as it is. It is stable to heat. So heat कर नहीं, boiling point तक it's an entirely different thing. उसमें तो हम देखते हैं कि एक molecule दूसरे molecule से कैसे टूट रहा है. Here we are talking about a molecule itself breaking apart. एक molecule के अंदर hydrogen और fluorine का अलग होना. Is this clear? So that does not happen. H and F do not break on heating. Neither does HCl so easily. HBr को अगर थोड़ी सी हीट करें या बहुत ज्यादा हीट करें तो ब्रेक कर जाता है. एंड हाइड्रोजन आयोडाइड तो अभी हमने देखा कि बनते हुए ही टूट रहा होता है. So this again shows the strength of the bond. We can also see this from the data of bond energy. HF has a very high bond energy. HCl has a little bit less bond energy. And HBr and HI, the bond energy tends to decrease. What might be the reason ये bond energy क्यों कम हो रही है? नहीं, intermolecular forces are an entirely different thing. इसमें कोई काम ही नहीं है intermolecular forces. We are talking about bond energy, breaking the H and the F bond. Intermolecular force होती है between one HF molecule and another HF molecule. उसकी बात नहीं करते हैं. We are specifically talking about one single HF molecule. उसको अगर तोड़ना है तो उसकी energy कितनी चाहिए? So why is that energy increasing as I go from HF to HI? Yes, you're right. So what reason do I have HF ka bond stronger, and as I go to HI the bond weakens? Why is that so? 9. The bond length. HI, iodine is a bigger atom, so HI bond length is bigger. दूर है वो, तो जब कोई चीज दूर होता है, I told you just like in judos or they tend to break a wooden piece. What do they tend to do? They tend to take a longer piece and attack it from the middle, and it easily breaks. So that analogy will help you understand this. Agar hydrogen iodide is a longer bond, the bond length is greater, so you can easily break it in the middle. But hydrogen HF, hydrogen fluoride, is a smaller bond. It's a shorter bond. If it's a shorter bond, it is difficult to break. Is this clear or not? And thus the high bond strength or the high bond energy. Is this clear? Is this clear? Bilkul, we have studied that in bond strength and bond energies as well. How longer the bond length, the shorter the longer the bond length, the lower the bond energy, right? So we can apply that phenomena here as well, and we see that it's an observation कि जितनी ज्यादा bond length है, because the remaining factors are the same. एक तरफ तो हमने hydrogen ही लगाया हुआ है, दूसरी तरफ we are changing fluorine, chlorine, bromine, and iodine, and with as we go down the group, the bond energy is increasing, and so is the bond length. Is this clear till this point? Anything that is not clear till this point? Next